In mechanics, any two perpendicular lines in a plane or three in space can serve as coordinate axes. And our goal is to choose them in a way that makes solving the problem as easy as possible. Let's say in a problem, we need to add two vectors, A and B. Graphically, that's easy to do, but to actually calculate it, we need to go through a few steps. Step 1. Choose the coordinate axis. Of course, in our explanation we will assume we already know all the angles we need. Step 2. Resolve each vector into its components along the axis. Step 3. Add the components along each axis to get the components of the resulting vector. Step 4. Find the magnitude of the resulting vector using the Pythagorean theorem. Step 5. Find the direction of the resulting vector using the formula tangent of c equals cy divided by cx. We see that the number of calculations is quite large, so let's try to simplify our work. Let's place the x-axis along vector A. That way, we don't need to calculate its components. Ax is just the vector itself, and ay is 0. To find cx, we add a and bx, and cy is simply equal to by. Of course, angle B is the new angle between vector B and the x-axis. If several vectors are aligned with the axis, our advantage becomes significant. In the first example, three forces are already directed along the axis, so we don't need to calculate their components. There is, however, an even more efficient way. In many problems, we already know the direction of the object's acceleration, and therefore, according to Newton's second law, the sum of all force vectors points in the same direction. Let's place the x-axis along the direction of the resulting vector c. Then, the magnitude of c is simply equal to ax plus bx. The main advantage of this method is that we don't need to calculate the magnitude of vector c using its components. An additional bonus is that the component cy is now 0. That is, ay plus by equals 0. This gives us one more convenient equation for solving the problem. In the second problem, we know that the object's acceleration is directed along the inclined ramp, so we will choose the x-axis in that direction. So, the most convenient way to choose the coordinate axis is to align one of them with the direction of the object's acceleration.